Variable speed motors have been used in residential and light commercial HVAC for over 20 years. And there's actually been 5 generations of them, with 2 generations still currently in production. They are built in 120 and 240 volt. They are built in 1/3, 1/2, 3/4, and 1 horsepower, and they are direct drive indoor blower motors. They're primarily found in high-end HVAC appliances, including geothermal, package systems, air handlers, gas, oil, and propane. But again, I want to stress they're primarily found in high-end systems, 2-stage, 3-stage, modulating, or again in a high tier if an appliance manufacturer only makes a single-stage product like oil. So what is the difference between an ECM and a PSC motor? Why is the variable speed motor so much better than a PSC motor? That's what we're going to talk about right now. The benefits of variable speed include precision and controlled airflow, meaning that a manufacturer can actually program the motor to provide the exact amount of airflow they want per demand, per first stage heat, second stage heat, first stage cool, second stage cool, and then have the motor automatically maintain that airflow even if total external static pressure changes, which of course is your filter getting dirty, your coils getting dirty, registers and grills getting closed, you know, all the things we deal with every day. It also can reduce the downtime or system repairs. So how can a motor do that? Well, if you have proper airflow across your heat exchanger and your evaporator, you're going to have less limit failures, you're going to have less frozen coils, you're going to have less service calls, which means you're also going to have less expensive equipment failures like your failed heat exchangers and your failed compressors. So constant airflow is a very big part of what makes variable speed technology so great for residential heating and air conditioning. It gives the system the ability to maintain airflow, which a PSC motor just can't do. There are other comfort benefits. Constant fan is usually not utilized by customers with PSC motors because a PSC motor usually runs too loud in constant fan and uses too much energy. The variable speed motor runs a constant fan that is so slow most homeowners will never hear it and actually uses around 100 watts of energy. How about a light bulb? Running the fan continuously, we know, improves destratification. In other words, in a 2-story home, it makes the whole home a little bit more comfortable by preventing the hotter air from rising and the cooler air from falling when the blower motor is turned off. And we also know that if a home has any indoor air quality products like high-efficiency electronic air filters or UV lights, running the fan continuously takes full effect of these products and gives it to the home. In addition, there's something called comfort profiles programmed into variable speed motors. And you're probably thinking, well, what's a comfort profile? Well, a comfort profile allows you to select in the motor whether you want it to operate in a dry climate or whether you want it to operate in a humid climate. In a dry climate, you want to get more efficiency and more sensible cooling out of the motor by running a longer off delay and maybe a little more cooling airflow. In a humid climate, you want to run a little less airflow for more dehumidification out of the evaporator coil. And you don't want any off delay, so you don't rehumidify that moisture back into the home. These options are just not capable on a PSC motor, but come standard on almost all variable speed products. Noise is another issue that variable speed can take care of. Noise as far as constant fan operation simply means when a PSC motor runs constant fan, it can't run slow enough to decrease the sound of that air moving through the registers to do it quietly. A variable speed motor can be programmed to run very slow. In other words, it can run the air very quietly through those registers. You get precise airflow for all demands. On 2-stage or even modulating products, you end up with the precise amount of airflow at that lower stage of heating or cooling, which is going to make the airflow through the duct system even quieter. And one more thing, if it needed any more, is called soft start and soft stop. What that means is that when the ECM motor turns on, it actually turns on slowly and ramps its way up to the speed that it's going to, as opposed to PSC motors that basically turn on and run as hard and as fast as they can to get to where they're going. So with soft start, soft stop, and ramping between constant fan and a heating demand call, or even a first stage and a second stage demand call, you get the motor moving from place to place without a drastic noise change in the home. And that's very valuable to many homeowners. And last but not least, electrical efficiency. The variable speed ECM motor, like all ECM technology, is an 80% electrically efficient motor. Now, what that means is 80% of the power the motor draws is going to be used for mechanical energy to drive the shaft, make airflow, and 20% of that power is going to be waste, turned into heat. A PSC motor is actually 60% electrically efficient, which means that it has twice as much waste heat. Now, we are talking about electrical efficiency here, but that also goes toward the reliability of the variable speed motor, because since it has less heat to dissipate, it runs cooler. So let's get back to the electrical efficiency. Now keep in mind that the average heating and cooling system runs about 3,500 hours, national average for the United States. While we're making the same airflow as a PSC motor, our electrical efficiency gain is around 20 to 25%. However, when you're running constant fan, that electrical efficiency grows because of the fact that the PSC motor cannot run much slower than about 900 RPMs by design, whereas the variable speed motor, because of its electronic controls, can run much slower. Many manufacturers will run the variable speed motor at around 600 to 700 RPMs, which actually runs the motor at around about 100 watts of energy. So two things happen when you run constant fan on an ECM versus a PSC. The motor can run slower, which obviously uses less energy, but the ECM also maintains its electrical efficiency. You see, PSC motors, when they start to slow down from high to medium to low speed, they actually degrade in electrical efficiency. Their peak is when they're on their highest speed and at a proper external static pressure. So if we remember that there's approximately 8,700 hours in a year, and we subtract the runtime of the heating and cooling system, which is around 3,500 hours on average in the United States, we end up with 5,200 hours of constant fan operation. That means 5,200 hours of indoor air quality and of destratification in the home. Now, when running a PSC motor for those 5,200 hours, we're going to be running at around 400 or 500 watts on low, medium, or high speed. That's all that motor can do. On the variable speed motor, the manufacturer can select as low of an RPM as they want to get that airflow very economical and very quiet, which is going to give the homeowner a reason to want to run constant fan because they're not going to hear it and they're not going to pay for it. So let's pull all of those benefits together of the variable speed ECM indoor blower motor. You have precise and controlled airflow. In other words, the manufacturer is going to give you the exact amount of air you need per demand in your system, and that airflow will be maintained even when static pressure goes up or down, and of course it usually goes up. Dirty filters, dirty coils, registers and grills, you know the drill. Also, increased electrical efficiency. So our motor is going to use less energy and do more work for us. And finally, improved comfort and reduced noise. We're going to improve comfort by having the proper amount of airflow going across the heat exchanger and the evaporator so we deliver the right amount of heating and cooling to the home, and we're going to improve comfort with our constant fan by destratifying the home. So what you have in variable speed ECM is a premium motor, you have a premium system, and you are providing premium comfort. One final thought on variable speed systems. Many contractors, myself included when I was in the field, were leery about offering variable speed systems to my customers because it is a high-end appliance, and with high-end appliances you get a high-end cost. However, what I realized is that buyer's remorse will wipe that out. Let me explain what I mean. When I install a standard system for a customer, it does the same thing their old system does. It provides the same heat and cooling, which wasn't the greatest. It's as noisy as the old system was, and I'm not running constant fan because it's got a noisy motor. So basically, the customer has buyer's remorse even though they bought a lower-end system and figured they were saving some money. If I install a variable speed system for my customer, even though it's a higher cost, I exceed their expectations. I give them everything and more of what they want. So keep that in mind the next time you're thinking about variable speed systems, and you might also want to check into credits and rebates through your manufacturer, through utilities, and through governmental agencies.